Good morning. So if you don't mind, let us do these homework problems. That is for the last lesson we talked about. There are three problems. Unfortunately, I realized there is one misprint there. Hopefully that I haven't wasted your time that much. If I did, so sorry for that. I formally apologize, okay? Okay, so now let us see what we can do. So the first question, in the base x, we have this relation. Then x is what? So x is a base in which you multiply 3, 1 in base x times 1, 3 to the base x. It becomes 1, 1, 2, 3 to the base x. We are supposed to find the base. I mean, even though it is considered to be a level question, but it is very straightforward. Okay, the first question, what I'm supposed to do? I mean, the problems from the base are not, the starting part is at least not complicated. You just need to expand. So what is this in base x? You remember we talked about in the lesson. So I have 1. So let me pick, so I write x to power 0, even though you don't have to, because x to the 0 is 1. And the next one is 3 times x to power 1. That's the expansion. Yeah. And then the second thing is more or less the same thing. So it becomes 3 times x to power 0, and then plus 1 times x to power 1. The same thing happens here, but it's a little bit more. So I have 3 times x to the power of 0, plus 2 times x to power 1, plus 1 times x to power 2, plus 1 times x to power 3. Yes? Do you agree? And I don't need any pair of brackets here. So what I did, I just used the meaning of the base to expand the numbers, yes? So let me simplify it, because no one writes like this. So how do we write? We write simply 1 plus 3x multiplied by 3 plus x is supposed to be equal to 3 plus 2x plus x squared plus x cubed. So in other words, the problem is asking you to solve this equation. And this equation is a third-degree equation, and you know that in general it is not easy to solve third-degree equations unless we can factorize. And intentionally I have chosen the numbers in a way that the factorization becomes simple. If I multiply that, it becomes 3 plus x plus 9x plus 3x squared. And I have 3 plus 2x plus x squared plus x cubed, yes? And that is the whole point. So I designed it in a way that it is not hard for you, because you see that these three are gone. So as soon as the constants are gone, it is not hard to factorize, yes? For example, let me move everything to the other side. So x cubed is already there. So I have 1x squared here. 3x squared goes from here to there. It becomes minus 2x squared. I have 2x here. Here is 10x. When I move it to the other side, minus 10x plus 2x is minus 8x. Do you agree with me? Yes, and it is equal to 0. Of course, still you see this is a third-degree equation, but extremely easy to solve, because you can just simply factor x out, and then it becomes x squared minus 2x minus 8 equals to 0. By the zero product rule, I have two numbers. I don't know those numbers, but I know that the product is 0. So it means either this one is 0 or the other one is 0. So this means that either x is equal to 0 or x squared minus 2x minus 8 equals to 0. You can use ABC formula or PQ formula, but I mean factorization for these small numbers is very simple. I ask myself, can I find two numbers whose sum is minus 2? And the product is minus 8. If that is easy for you, this is the faster way. Okay, otherwise don't waste your time. You can use PQ formula in this case, because this is already 1, this is even. So can you guess those numbers? The sum is supposed to be minus 2, the product is supposed to be minus 8, yes? Minus 4 plus 2. Do you agree? If I add them up, it becomes minus 2. If I multiply them, it becomes minus 8. And again, I use the zero product rule once more. Either this one is 0, which means x is 4, or this one is 0, which means x is minus 2. So this equation has 3 roots, but be careful. You have to interpret x as the base. And we learned that the base is a natural number, at least 2. Okay, so b is a number natural greater than or equal to 2. So it means that there is only one acceptable solution. And that acceptable solution is just x equals to 4. So it was not very hard, by the way. This is an A-level question in the topic of bases. Any questions? Okay, so now we go to the next question. This is a little bit harder one, but at least again I told you, even if you get a harder one, you cannot finish it until the end. You can still do something reasonable and get some points. Okay, so let us read the question here. They are telling you that in every base A, this relation holds. Okay, and then you are supposed to find this x here and then write it here. It's a little bit more challenging problem, so let us try to see how it works. So, how can I solve that? At least the starting point should be simple, yes? So I need to expand them. There's nothing to do. Okay, so here, what do I write? But let me do it faster this time. The first one is 0, so nothing. 1 times 8. Do you agree this is nothing except 8? Yes, because 1, 0 to the base A means 0, a to power 0 plus 1 times a to power 1. But this is completely gone, I get A. Yes? What about here? It becomes 1 plus 1 times a to power 1, which is a. And this one becomes 2 plus a. And this becomes 3 plus a. And then I have 1a at the end. So this is, let me just call it the left-hand side. Because on the right-hand side, I can do nothing. I don't know what is x. So there is no point to expand that because I don't know x. And I don't know how many digits are there in x. So there is no point to work out with something on the right-hand side. But the problem is, I know something. I know that I have to expand. And because on the right-hand side, I have the same base A, my expectation should be to write something in powers of A. Because on the right-hand side, the base is still A. So that is the only thing I can foresee before starting. Okay. But expansion, my point was to expand it in a clever way. Of course, if you multiply one after the other, it is not that hard. You can expand that. But then you get a polynomial of degree 4. You might not be easily write it as a polynomial to power 2. If you can, that's okay. You just expand that and then see if you can see this result is something to power 2. If you can that, you can do this. But my goal was to do it a little bit more clever. I have to multiply 4 numbers. The order of multiplication is under my control. Whatever I want, I can do that. And the grouping, I can do that. So I decide to multiply this by the last, and I multiply these together. And you will immediately see why. Because if I multiply this by that, it becomes a squared plus 3a, yes? And then if I multiply these two together, so what happens? A times a is a squared. I have 1a from here, 2a's from there, so in total 3a. And that was the reason, you see? Something common occurs if I do it in this way. And then, of course, 1 times 2 is also left. Yes? And then I have 1 at the end. Okay, the next one that I hope that you can do it a little bit if you are good in algebra, might be it is not hard to see. I will take this one, and in my head, I will decompose it into 2 parts. One part which is the same and is common with them, and then extra 2. So how can I multiply? I can multiply this by that, plus this by this, yes? If I multiply this by that, what happens? It becomes x squared plus 3a to the power of 2. And then if I multiply this by 2, it becomes 2. You see, the idea is again the idea of auxiliary variable, yes? And then I have 1 at the end. But I don't know, can you see the pattern now? Keep it in mind. For example, I don't know, consider that a squared plus 3a is your capital X. So then what happens? This is nothing except capital X plus 2x plus 1. And I think everyone knows what is the pattern. The pattern is what? X plus 1 to the power of 2. And that is good, because on the right-hand side, I need this power of 2. So that was a little bit clever way of multiplying things, okay? Okay, but at least if you have written something like this, it means that, I mean, even if you just expand that, it will work, but it is harder for us to detect that pattern. Okay. Anyway, so what can I continue? I can continue and write x, capital X plus 1 squared. But what is capital X? Capital X is a squared plus 3a plus 1 squared. So, are you happy so far?
Yes.
Okay. But now, because I know that on the right-hand side, I have to write my number to the base a again, I should be able to interpret this as a number in base a. And it is, yes, because it's a number with powers of a going up. So this is the units digit, and this is the digit next to it, and this one is the digit next to it. So how can I write that? 1, 3, 1 to the base a. If you don't understand, do it again. If I give you this and I ask you to expand this, do you agree with me? You expand it in that way. You write 1 plus 3 times a plus 1 times a squared. Okay, so here the question was if you understand your polynomial can be interpreted in this way. And then of course I have a power of 2 here. So I started from the left hand side, I reached to this. And I have it this one on the right hand side. Just compare them. So what is your x? 1, 3, 1. Is that right? So x is 1, 3, 1. Yes? Okay, so be careful. So every polynomial can be for example, let me test your understanding again. If I ask you, can this polynomial be interpreted as a number in some base x? Yes. What can I interpret this? 3 on the units digit, 2 coming next to it. What comes next? 1, the coefficient is 1. What comes next? 1 to the base x. So you see that? If I ask you open it up, this becomes this polynomial. Usually people are good in open it up, but they are not good. They open up, they leave it for others to pack it up, yes? So you have to also have this feeling that you mess things around, you just fix it and go back again, okay? So the last question, which unfortunately I made a misprint, you will see the corrected version. The question is this: if the remainder of u v w to the base 5 by 31 is 17, the remainder of vw to the base 5 by the same number 31 is what? Unfortunately, when I typed it for you, I just wrote it the other way around. I wrote WVU, which is not this one. So this is the correct way, okay? Okay, so yeah, think a little bit about that. And I don't know why I have given it 1 point anyway. So this is a little bit harder one. The algebra is, by the way, very simple. The algebra is not hard, but you have to have a good understanding. This is a connection like the problem in the book. Do you remember? There was some problem in the book that it was related to the bases and congruency. Yes? But they have it directly mentioned you that simplify this number to this module. But here, I have actually make it a little bit unclear what to do. Okay? But again, the starting point shouldn't be hard. So if you don't mind, let me write it here on the board now. So we know that u v w to the base 5. And do you remember what is this line? Of course, here, because you have this base, I really don't need to put that one because people understand that this is a 3-digit number. But if this is not there, usually people put this one so that you don't read this multiplication. So that's not a big problem. So, can you translate the first sentence into mathematical language? Let us just translate this English sentence up to here into mathematical symbols. How can I translate that? You are dividing this number, whatever it is, by 31, and you are getting remainder 17. This can be interpreted in 2 ways. One, using division algorithm, but division algorithm is more or less obsolete now. After we learn modular arithmetic, you don't have to go back to division algorithm that much. It doesn't mean you don't need to know it, you have to know it, yes? But it is better to do everything using congruency as much as we can. Okay, can you just translate that sentence? This number divided by 31 has remainder 17. What does it mean? Yes, Sabri? It's congruent to 17, congruent to 17 module 31. So that's the translation. And let us again translate what is wanted. The remainder of VWU to the same base 5 by 31 is wanted. So what does it mean? It means they are asking about V, what was that? W, U to the base 5. They want you to answer this question. That now if you simplify this number to the same module, what will be the answer? And one more thing, you should also be careful. You cannot answer anything you like here, even though it is correct. You have to have a limitation. From the lower end, the minimum value should be 0, and from the upper end, the maximum value is 30, because it is strictly smaller than 31, so it means that it goes up to at most 30. And of course, integer, yes? So that is the question. Okay, so that is the formulation of the problem in math language. But what should I do? I don't know. Okay, so I have to do something. So, yes?
Can we rewrite the first number as 100u plus 10v plus w?
Not 100. The base is 5.
Oh, yeah, times
What you said is based on 10.
Oh,
Yes?
okay.
So here, yes, that's the idea, because I don't know what to do. So I have to open it up to see what happens. How can I write this? This is extremely simple. I start with W. Can you tell me what is coming next? The next digit multiplied by 5 to power 1. So it becomes 5V. The next digit multiplied by 5 to power 2. So it becomes 25U. Is that right? I did nothing. I did the same thing. Yes? Are you confused or not? I'm just expanding this. But this is not something I have to calculate. This is already given to me. This is granted. But then I go to a scratch paper because I want to find a connection between what I have and what I want to find. Otherwise, I cannot go forward. Okay, I will do the same thing here. So I try to expand this one and to see if I can find some algebraic calculation that takes me from here to here. Okay, how can I expand that? I can write U plus, say something, you have exam on Monday. 5 what? W plus 25V. So the question is, can I answer this one? Yes? Okay. By the way, it's not useless. If you just write these two, you get some points. Because at least you understand what you're supposed to do. Okay? But can you tell me, so this is not that easy to see how can I go from here to there. Okay? But I want to wait a little bit for you so that you can find a way. Okay, so the idea is clear. Using this piece of information, somehow, I should be able to answer this question. Of course, at least there are some similarities. UWV appears, UWV appears, but of course the coefficients are different. So you have to think in a way, how can I go with these coefficients to those coefficients? Okay, yes? Do you want to say something?
No.
Okay, think a little bit, because I want to go to the problems in the book. Try to multiply the left-hand side by an appropriate number, yes? So that somehow you can reach to that combination. And when I said multiply, I don't think it is now hard to see what number it should be, if you think logically. For example, compare the difference between what you have and what you want, and I gave you the hint that multiply the left-hand side by a number. If you knew that you were supposed to multiply, there are not that many options available to you. Do you have any idea what number I'm talking about? Yes, Omar? 5. I will multiply by 5. But do you see why? First of all, 5 is not bad. Because here W is I want what? 5 doubles. Okay, so let us multiply by 5. Let us see how it happens. Okay, so what happens here? I multiply everything by 5. You know that I am allowed to multiply both sides of congruency by any number, of course, except 0. And then I multiply this by 5, it becomes 25v. And I multiply this by 5, 125u. And I multiply the right-hand side by 5, it becomes 8531. Yes? I consider this A-level problem because it is not easy to understand this in this way, but now that you have experience, might be it is not anymore a label problem. But can you see the problem is solved now? First of all, this coefficient is good. That's exactly what I want. Another one is exactly what I want. Yes? But I have one problem, and that is no longer a problem. Why? 125 is 1. Yes or no? 125 is 1. We are working in modules. 125 is 1 when it comes to module 31. Why is that? Because 125 minus 1 is 124, and 124 is divisible by. That's finished. So you just need to multiply by 5. Yes? You see, the algebra is minimal, but I would consider it a hard problem if you haven't seen this before. But now you have a little bit of experience, so be ready for harder questions in the exam. Yes? Yeah, because now you have experience. No, I'm kidding, okay? So this becomes what? U. 125 is U, 1. So it becomes just U. I just copy and paste the rest. 5W, what? What? 25. 25, V is congruent to 85, module 31. And that is exactly the combination I made. The problem is, this is not acceptable because it is not in the range, but that is an E-level question. I have to go back to a number which is acceptable. So can you tell me what is another name for 85 in this module which is acceptable? 23. Yes? Why is that? Because 85 minus 23 is 62, and 62 is divisible by 31. And this number is now in the range that I wanted. So the answer to the problem is just simply 23. So it was not, I agree. I mean, algebra is minimal. It doesn't mean it is not hard. If you haven't had experience with these kinds of problems, I consider it a little bit hard problem. Yes, please.
What's the original question?
The original question, the reason I was trying to solve it for you, and then I said that it is not working. I said that how is that possible? Because I remember when I was designing it, I designed it in a very simple way, then I couldn't solve it myself. Okay? And then I said that, okay, might be I had made a stupid mistake. Then I see that in my notes, because I always scan my notes, I mistyped that. And so that the original one, there is no guarantee the original will work. Yeah, so that's what I'm saying. Don't think that because I could solve this problem, any combination will be able to solve. You can think about it, yes? But at least I thought about for 5-6 minutes, and I realized, no, it's not working. That's why I went back to look at my notes when I was writing the question. I realized that when I was typing, I was confused. Because in the original one that I gave to you, UVW, and I wrote WVU, the other way around. So that's, I don't know, for some reason I did it wrong. Any questions? Yes? Okay, so I will stop here, this recording at least. Thank you.